Hello, we are Group 2, and we'll be presenting our web app, Auctora. Auctora is a platform for buyers to bid on watches that are auctioned on eBay and track various watches. This video will demonstrate the various functionalities of the app and also how we leveraged Azure services and eBay APIs to add features to our app. Auctora aims to provide the user with a platform where they can search for watches, bid on them, add the watches to their watch list, view similar watches, add reviews on watches, view analytics about the most popular brand, condition, or display, and also view recommended watches based on their reviews and search history. I will now go into more detail about each functionality implemented. Let's start by logging into the web app. Let's move over to the product search page where we can search for watches. This is the search page which allows the user to choose a combination of filters. Once the user has chosen the filters, we query the eBay Finding API to retrieve watches that are on auction on eBay. The specific operation we used was Find Items Advanced. When we make the API call, we get a list of products returned which match the filter criteria selected. The response is returned in the form of XML. We parse the XML and display details about the filtered products on the web page. This helps the user get access to live, up-to-date auction information from eBay. We can see the price of the product, the countdown timer showing how much time is left for this item until it expires, and also the number of people who have viewed this item on our web app. The user can also sort the results by price or any other attribute. We store new product results from the search into our database. If we get a product returned which already exists in our database, we keep a count as to how many times each product has been searched or viewed. We provide 4 main features that allow the user to place bids on watches, add the items to their watch list, add a review for that item, and display all the reviews for that item. We can start by placing a bid on the item. As we can see, we are alerted that placing a bid will automatically add the item to my watch list. After placing my bid, I am redirected to my watch list page where I can view all the watches that I am currently tracking. The second feature allows users to track various watches by adding them to their watch list. We use Azure Web Jobs to regularly update the products table in our database. We set up a cron job that runs every day at 9:30 a.m. This gives a dynamic feel to the site as prices are regularly updated. We also made use of the eBay Shopping API to help with regularly updating the items in our database. We used the Get Single Items operation from the Shopping API in order to update the item details within our database. We used it to update the current bidding price and its status of sale. The API call was made using a Python web job script on Azure. The response of the API call was in the form of JSON. This was then parsed and the details were updated in the database. Any watches no longer active were marked as inactive in our database and no longer displayed in the watch list. It is important to understand that the item is not deleted off our tables as it is used in machine learning. The item is just marked as inactive, and inactive items are not displayed on the site. The watchlist page also allows the user to view similar watches to the selected watch. We made use of the eBay Merchandising API to help with this task. We used the Get Similar Items operation from the Merchandising API in order to find related watches on eBay for a selected eBay watch. The related watches returned will have similar attributes and pricing to the selected watch. The response of the API call is in the form of an XML. The response has been constructed to return 5 similar watches. The details of each watch, such as price, are passed on a loop from the XML response and displayed on the web page. Since our database is just a subset of the eBay database, we might not have some of the watches returned by the eBay Similar Items API. Unfortunately, we cannot add the items returned by the API to our database as the information about the items provided by the API is incomplete and excludes some important attributes that are key to the functionality of our database. It is for this reason that we have decided to split this page into 2 sections. One that shows the items that we cannot host on our database, and another section that shows items that we currently have in our database. Users can also delete items from their watch list if they decide that they no longer want to follow a watch. Some other features we provided to the user are the ability to add and delete reviews, and also view all the reviews for a particular item. We make use of Azure Text Analytics or sentiment analysis on the reviews, and this allows us to combine the rating provided by the user and their review into a single aggregate rating. The following code shows the getSentiment function that retrieves the sentiment from the Azure Text Analytics API. Once we receive the sentiment, we rescale it from 1 to 5 and average the sentiment with the rating provided by the user to obtain a single rating, which is then inserted into the database. This page shows the personalized recommendations for the user. We used Azure Machine Learning Studio to create a recommendation system that studies user preferences and suggests watches depending on these preferences. We used the Microsoft Matchbox algorithm to help us with this task. The Matchbox algorithm takes an input tuple of 3 elements: user ID, item ID, and rating. This recommendation system also studies the filters that the user selects when searching for products. Depending on these filters and the items searched, we provide the user with tailored recommendations. This diagram displays how the hybrid recommender works. We import the data from our tables, clean it using the Python script, and then pass it on to the Matchbox recommender. We converted the Azure ML service into an API, which can easily be integrated into our system. This page shows some overall real-time analytics to the user, such as the most popular display, condition, and brands of watches searched on our system. Displaying the analytics in real time involves using Stream Analytics, Azure Data Factory, and Azure Blob Storage. We split this task into 3 main processes: Stream Ingestion, Stream Analytics, and Storage and Presentation. Let's start with Stream Ingestion. The Data Factory creates a pipeline between the SQL Server and the blob storage. Each time the Data Factory is scheduled, a table from the SQL database is transferred via the created pipeline and is stored as a blob in JSON format in the blob storage. The data is copied from the auction.filters table and stored in the Auctora blob every minute. The second stage is the Stream Analytics. If Stream Analytics is active, each time a new file is pushed to the blob storage, it identifies it as an input event. The Stream Analytics job converts any file received in the blob storage, applies the analytics to it, and stores the analysis in a new table in the database. We provide an analysis by counting the number of views to determine the popularity of products by brand, type, and condition. The category with the highest number of views is assumed to be the most popular. The last stage involves displaying the results to the user. In our system, the output represents both the SQL Server and a separate blob container. The blob container is used for testing purposes, while the SQL Server stores the processed data, which is further pushed to the front end in the form of charts. Auctora aims to provide the users a platform where they can buy watches, add them to their watch list, identify the recommended ones, and even bid. In order to offer the user a better experience, Stream Analytics is implemented with the purpose of displaying information in charts regarding the trending watches and what other users search for, such as the preference for analog watches over digital or the highest desired brands. We created a page for each type of popularity analysis that draws on the table populated by Stream Analytics to retrieve the number of counts and display them in graphs accordingly. As we can see, the page displays the graphs for brand, condition, and display popularity.